This is the way that Linux manages the permissions of who can do what with a particular directory or file. Oftentimes, when you download a new file off the Kali repository or you get it from GitHub, it's going to come into your system, and by default, it's not going to have any execute permissions on it. And if I go ahead and hack, one of these files, as a regular user, very often I don't have the execute privileges. And so what I want to do is I want to get in as a regular user, because regular users are usually easier to hack. Well, usually the admin or the root user is a little more security conscious.
I really want to thank Brilliant for sponsoring this video. Do you know how technology works? As an example, how strong passwords work? Should you be using a alphanumeric password, or just passwords with digits in them, or passwords with alphanumeric plus special characters? But do you actually know why? And do you know what a difference it makes when you change your password length, as an example? Let's say you've got a 4-digit password, really bad idea, and you add an additional number to that 4-digit password. By how much does the number of equivalent passwords increase? Do you know the answer? Is it 25%? Does it double? Does it increase by a factor of 10? Answer is it increases by a factor of 10. So for number-only passwords, the number of possible passwords is 10 to the n, where n is the number of digits. But notice, if a hacker can guess 1 million passwords per second, and that's not an exaggeration, that's very possible. If your password length is 3 characters, it takes about 100 microseconds to crack it. If you set your password to 7 digits, it takes 10 seconds to crack. 8, 2 minutes. 9 characters, 17 minutes. 10 characters, 3 hours. Notice, just by increasing your password length by 1 character, the amount of time it takes to crack increases a lot. But what you should be doing is making it harder to crack by using a variety of characters. Notice the difference between digits versus alphanumeric passwords. How many characters does an alphanumeric password need to have to be as strong as a 9-digit numbers-only password? Notice 9 digits should equate to 5 alphanumeric, and that is the correct answer. This course interactively teaches you why you should be using better passwords, or longer passwords, mixed character passwords. Make sure that your passwords are of a good length and use mixed characters. Now you can try everything on Brilliant for free for 30 days. Use my link below, brilliant.org/David Bombal. You'll also get 20% off an annual premium subscription. You can really change your life through education. And I really want to thank Brilliant for doing that, but also for supporting my channel. Hey everyone, it's David Bombal back with OTW. OTW, great to have you back.
Thanks, David. It's always an honor to be back on the best IT and cybersecurity channel on YouTube.
Really appreciate you saying that. As I always say, a big reason is because of you. And I will say this, I've had a lot of complaints about you. People have been complaining that you haven't covered chapter 5. I'm hoping that's what we're going to cover today, right?
That's what we're going to cover today. We're gonna fill in that gap. We kind of skipped from 4 to 6 in my book, Linux Basics for Hackers, which, by the way, we should have soon a second edition coming out. And so what we're doing here with you and I on this YouTube video is we're basically doing the updates that'll take place in the new book. So this is all, it's not the old version, it's the new version. So your viewers get a glimpse of the latest and greatest stuff that's going to be coming out in the new version.
I love that. So permissions, right? It's a big one.
Permissions.
I think many sites get hacked because the permissions are set wrong. So I'm hoping you can teach us, directory permissions. I think a lot of people struggle with this. I mean, 777, probably not a great idea. But I mean, take it away.
Well, let's first of all talk about the idea of file and directory permissions. First of all, there are different types of users, like there are in Windows and like there are in Mac OS. There's different types of users. There's each user has their own files, and of course there are regular users and there's administrative users. And you don't want to have all of them have the same permissions. As a matter of fact, you certainly want the root user, the admin, to have all permissions, but you don't want a regular user to have all of the permissions. And so this is one of the things that we'll be working on here And we're going to be looking at how we can change permissions, right? One of the things as a hacker or admin or anybody working in Linux is that when you install new software or you create new software, you don't necessarily have permission to use it. And so one of the questions I get very often is like, well, I just installed this new software and I got it from GitHub and it tells me I don't have permission to use it.
Yep.
Well,
Yep.
by default, it comes in without your having permission. You have to change the permissions to allow yourself to execute it. It's also this idea of permissions can also be really important from the hacker perspective in terms of permission escalation, right? Being able to escalate privileges. So oftentimes when a hacker gets inside of a system, they come in with the permissions privileges of the person who they hacked. And that person often doesn't have a lot of privileges. And so understanding permissions, privileges, pretty much we're talking about the same thing, is important from a hacker and from an admin perspective as well. This is Kali 2023-3. So it's,
Yep.
it's late last year, but it's pretty current, right? And permissions are not going to really change based upon version. So yours is going to look a little different, obviously, because I've got, some files in here that you may not have, probably don't have, all right? But one of the things we want to point out is that over here is where our permissions are defined, all right? This right here defines who the user who created it, who owns it. Okay, usually that's who created it. And this is the group. This right here is what we're going to be focused on today. And what this is tells us who has permission and which permissions on this particular file. So we can see here that there's a dash. This is a 3D chess. It has nothing in it. I was making this for as a piece of malicious software. But here we see that first of all, it comes up with a dash first, right? And the dash, okay, means that it's a file, right? That's what that means. Then if it has a D, like here, that means it's a directory. And then you'll see 3 sets of permissions right here. And then it starts with the R dash dash and then R dash dash. All right. So the R means read, the W means write, and this one right here, which is a dash, and down here you see it's an X. This is execute. This is who can execute this particular file. This right here denotes the owner of the file. All right, the first 3. So it's read, write, execute. And then this is the group, and this is read, write, execute. Only the read permission is open. That means that the group can read the file, but they cannot write to the file, and they can't execute the file.
Execute as in run the file, right?
Exactly. Yeah, it doesn't mean you cut their head off with a guillotine. It does not mean that. Right? Execute means running the file, and then you have for everyone else the read, and then says no write, no execute. Let's look at one that has almost all. Here's a new tool that I've been playing with that hopefully we'll be able to do in a future tutorial. It's called Blue Ducky. Blue Ducky allows us to be able to send commands into a Bluetooth-enabled device, such as an Android phone. But you can see here, it tells me that it's a directory and then has read, write, and execute permission for the owner. That's me. And then it has read and execute for the group. And then it has read and execute for everyone else. This is the way that Linux manages the permissions of who can do what with a particular directory or file. If you're wondering about some of these others here, these dates are the dates that they were created. This here is the size, all right? You can see that all the directories are 4,096, which is a standard size for a directory. 4096, right? And files can vary from 0 to any size at all. This BDADR is 22,000 bytes. This is how we can view the permissions on files. So I use the ls-l. If you just use the ls command, all right, let's do that. Then we do ls command. You don't get that information. That's why you'll see me always, when I do a listing, I do what's called a long listing. That's the L is long listing, because I like getting that information. And I don't know, I like laying it out into a table like this versus putting it all over the place like LS does. This to me, this is not very useful, right? But to each their own. I'm not going to tell people how they should go ahead and use their Linux. One of the beauties of Linux is that it allows everybody to do things slightly differently if they want to. Now, let's talk a little bit, about these permissions. And I've got a diagram here that I think might be helpful to your viewers. Okay, this is understanding the Linux file permission. We can see here that what it's doing is it's taking this section right here, these three triplets, and breaking it down. So the very first column, like I said, it's a directory, a file, or link, okay? So this very first column indicates whether the file is a directory, it'll have a D, okay? If it's a file, it'll have a dash. And if it's a link, now a link is simply, if you're coming from a different operating system, you know that there's links on your desktop you can click through that'll take you to another file. Same thing applies in Linux. And so if it's an L, it's going to be a link. And maybe in a future tutorial, we should talk about links. But
it's confusing.
This is not a good time to do it right now. But then you can see what I was discussing earlier is the RWX. So this is the very first column of this triplet is the R. The very first column of this triplet's an R, and this one here is an R. So they just simply denote the permissions of the user, the group, and everybody else or others. So while the first column defines a directory, file, or link, the next three columns define the permissions of the user, group, and the others. So we can then look at these permissions and we can assign them numbers. Well, basically what they are is, remember that everything underneath a operating system or every digital system is basically a 0 or a 1. And so remember that the far right column is the lowest number. Okay, that's the 0 or 1. The second to the left, then going left, is going to be the 2's column. And then the third one is, so this would be the 1's column, this would be the 2's, and this would be the 4's. Hopefully that makes some sense, right?
Yeah, people need to learn a bit about binary. I'll link a video below if people struggle with binary.
Yeah. Okay, this is base 2 binary system. So when we're talking about permissions, it's basically going underneath to the binary to assign numbers. So if this X is turned on, execute permission, it's designated with a 1, because that's what that column's value is in binary. This column in binary is either on or off, so it's either 2 or 0. And so if it's on, it has a value of 2. And this column is the 4's column. Once again, this is the base 2 system. If it's turned on, it's a 4. So if all of these are turned on, all these permissions are turned on, you can sum each of these, 4, 2, 1, and it comes out to 7. So all the permissions are equivalent to a 7. The same applies to the group, and it applies to everyone else. So if we have all of the permissions, right, if all the permissions are turned on for the owner, the group, and everyone else, it's going to have a numeric designation of 777. That means all the permissions are turned on. That's probably not a good idea. But sometimes, sometimes that happens. It does. One of the most important commands that a beginner needs to have in being able to work with permissions is, how do I go about changing permissions?
Yeah.
So let's go ahead and do that. right? There's a command in Linux called change mod. And you can see here, this was the Blue Ducky. This is that piece of software that allows us to inject commands into Android or any Bluetooth-enabled device. And what I had to do is after I downloaded Blue Ducky, I had to set the permissions because there were no execute permissions on it. So what I did is I had to go ahead and change it to 755. So what does that mean, 755? That means that I, the owner, have all the permissions. The group, okay, has read and write, read and execute permissions, and then everybody else has read and execute permissions. So let's just go ahead and do that. When I do that, it comes back and says no such file or directory. Why? Because I didn't use the sudo command. All right, so let's go change mod 755 Blue Ducky GUI. Hopefully we'll do a video in the very near future on how to use this Blue Ducky. All right, it asks me for my password and cannot access Blue Ducky PY. No such file or directory.
Oh, it's in a different Blue Ducky directory, right?
It's got to move into the Blue Ducky directory. Yeah. Let's just do that quickly. All right. And then up arrow and then change. Okay. Now let's go ahead and take a look at that Blue Ducky. All right. You can see here's the 7 and here's the 5. So it's 4 and 1. And here's 4 and 1 also. Now let's assume that I don't want anybody else to execute this but me. I don't want anybody else. So one of the things that I could do is change the permission so that only I have access. I can execute it. I can do that by using go sudo change mod, right? And then go 744, right? Blue Ducky. Let's see what that does. And now let's go ls-o. And you can see now only I, the owner of this file, can execute it. The others can read it, but they can't execute it. Now, if I wanted to, say, limit the permissions that nobody else could even read this file, I could do that as well. Let's go up arrow, and what would that be? So I would want myself to have all the permissions. That would be a 7. And then, say, I wanted everybody to, say, have no permissions. And I could do 700. Right? And now, if I do ls-l, you see, here's what only I can read, write, or execute this file. Nobody else can do anything. They can't even see it. They can't read it. They can't write it. And they can't execute it. Right? So this is where the change mod becomes really key. Oftentimes, when you download a new file off the Kali repository or you get it from GitHub, it's going to come into your system, and by default, it's not going to have any execute permissions on it. So that's where the problem comes in. You have to go ahead and give yourself permission. And usually, I often will just go in with a change mod 755. You can do whatever you want. But it's important to note that if you want to give execute permissions, the number must be odd, right? Because the read permissions are 4 and the write permissions are 2. So any combination of those is always going to be an even number, and it's always going to be an odd number when you give execute permissions. So that's the one, right? So that's key in being able to use the numeric form of change mod, right? There's also what's called the Yugo version. All right, let's take a look at that. Okay. Yugo it allows us to remove and add permissions by using letters and pluses and minuses. And some people like this better. I like the numeric version, but to each their own. So let's go once again working with this Blue Ducky. And let's say that we wanted to add that the group has execute permission. So we could go sudo change mod, and let's go G plus, and let's go execute to Blue Ducky PY. All right, so this says add the execute permission to Blue Ducky, And let's go ahead and hit that. And now let's do ls-l. And you can see that the group now has execute permission. So the difference between these two methods is one uses the numeric method and one uses this kind of symbolic method where you use letters to indicate G for group, okay, O for owner, okay, and U for all the other users. So let's go ahead and let's just test it out. All right. That's the best way to find out. Right. Always, if you're not sure, try it out. All right. So let's go O, okay, and plus, in this case, give it execute plus execute and go blue. You can tell I don't use this method very often. I like the numeric method. So this is, I said that O, okay, and then let's go and take a look at, all right, and you can see that O, the others, I added execute permission for it. Let's try just a few others just to get a feel for it. Let's go and let's go with the groups, okay, and say I want to add the group and I want to add read permission. So this says for the group, add the read permission to Blue Ducky. Let's go ahead and then go ls-l. And you could see that there's the read permission has been added, right? You can see up here, there's no read permission. And here we've added the read permission. And then one more, let's try, let's go to the others. Let's do -x. All right. So this is like, I'm going to take away the ability for others, the people, all the other people on the system to be able to execute this particular file. So I'm going ahead, others minus take away the execute permission. And look at, see up here, we see the others have execute. And now if we do an ls-l, you can see it's gone. Right? So those are the two primary ways of being able to change permissions. All right. There's an awful lot of other things that we can do in terms of permissions. One of the things that happens from a hacker perspective, let's talk about that. There are some special permissions. All right. And these are called the sticky bit. Okay. So in addition to these three special permissions, Linux has three special permissions that are slightly more complicated. These permissions set the user ID or SUID, set the group ID or SGID, and the sticky bit, right? The reason that these are important is that the sticky bit essentially allows users to be able to temporarily use a particular binary file for a moment. So sometimes you don't want necessarily to give the user permission to use it all the time, but maybe in certain instances, they want to be able to use it. And so let's go ahead and take a look at that. And sometimes by understanding that there's this sticky bit that can be set, I can use that as a hacker to get read permission. So in some cases, let's take a look and use the find command to be able to find those files that have the sticky bit set. The sticky bit allows a regular user to be able to use a binary with root privileges for a momentary access. And so one of the things we might want to do is, if we know this, what files have this momentary root access, we might be able to use that to be able to escalate privileges. And we can find the files, okay, to have that by using the find command, and then go -user, and then root for permissions, then -perm, all right, and -4000, all right. Let's see if I've done that correctly. There we go. Now, to give me all these permissions denied, let's go ahead and run it again with a sudo. All right, let's go up arrow again, do sudo. And what this is doing is it's showing us all of the files that have the sticky bit set. And there's a lot of it. And this allows a user to temporarily use that binary file as the root. And this is a good way of finding those. I'm going to go ahead and stop the search, but let's just simply look for those that are, let's go back and is look at this find command. Okay, find, says start looking at the root of the file system, and let's look for the user root, and find those that have permission. 4,000. 4,000 would be the sticky bit set, but let's be even more specific. And let's go and look just in the binaries. And let's go user, just in the binary files. We don't want to look at anything else. And let's go ahead and hit that. And it's much smaller set. All right. And you can see these are all the files that have the sticky bit set. Right. Things like new group, right? Unmount. And so this is a way to be able to find those. Here's user bin password. When you're changing passwords, you have temporarily have that access with root privileges for the moment that you're using it, and then they come on and then they leave as soon as you're done accessing it, right? So this can be really useful, right? If you identify these files, and sometimes you can manipulate those to be able to get privilege escalation. Privilege escalation is one of those things that any hacker needs to be familiar with. Why? Because normally when you hack a system, you come in as a regular user, you can't do much as a regular user, right? Because the regular user doesn't have permissions to execute. But one of the ways that you can escalate privileges is finding files that have the sticky bit set. And that's what we just did with using the find command. Now I can go ahead and potentially, not always, but potentially be able to use that momentary root privileges by running that binary to escalate my privileges to be able to do something a little more nefarious and malicious on the system.
We'll have to get you back sometime to do that as well.
Yeah, we'll be happy to do a privilege escalation, especially in Linux. We don't cover that in the Linux Basics for Hackers in this book, but we do cover that as one of the classes in the Hackers Arise subscriber class set, right? As we do privilege escalation. It's one of the key tools, one of the key skill sets that any hacker has to do, because very, very often when you hack a system, you're coming in as a regular user. Let's go ahead and remember this here. Let's take a look. And if I come in as a regular user, I have no privileges on Blue Ducky here, or any of the others too. If I go ahead and back up, let's go back up a level and then go ls-no. And if I go ahead and hack, one of these files, as a regular user, very often I don't have the execute privileges. And so what I want to do is I want to get in as a regular user, because regular users are usually easier to hack. Well, usually the admin or the root user is a little more security conscious. They're less likely to click on a malicious link. They're less likely to be able to be social engineered. And I've said this before in other videos, is that most hacking takes place as a type of social engineering, right?
Yeah.
There are attacks that don't require any click, like Pegasus is a good example. Eternal Blue is a good example. And there's others that are out there that don't require any interactions by the end user. But probably 80 to 90% of the hacks require some interaction with the user. That's basically requires some social engineering. Social engineering then gets somebody to click on it, and you're much more likely to be able to social engineer a regular user than you are a root user. Now, I'm making a generality here, and it's generally true. It's not going to apply in all cases. In some cases, there are root users, there are admins who are lazy or busy, and they do click on links that they shouldn't. I get a lot of links sent to me every day. Some of them are very, very convincing. Others are not so. All of us have seen, the Nigerian prince social engineering, but many of them are much more sophisticated and have they're written in good English, and then they have HTML that indicates they came from a source other than they actually did. But, for instance, I think I've mentioned the one where I got one from my mobile carrier. And it looked exactly like my mobile carriers, or one that came from the IRS. It looked just like an IRS message. And they needed me to click on this link to be able to pay my bill or recover my refund on my taxes. And so those comprise probably 80% or more of all hacks. Now, even when we're talking about nation states, right? When we talk about nation state actors, they are relying upon social engineering as well. So don't think it's just like the dumb people who get hacked with social engineering. The nation state actors are doing this as well. They're sending email messages and with links and documents, asking people to open them. I think I got one today. I don't know if it's from a nation state actor, but it's let's see. I get the ones where my account has been closed or temporarily closed, or I need to click to because it's a new security regimen that that they're using. I mean, those are very common, and sometimes they're convincing. And I'm cautious of everything. I mean, I'm very skeptical of everything that comes in my email, even if it comes in my inbox versus my spam. I check my spam regularly because spam filters are not foolproof, right? So if I didn't check my spam mails every day, several times a day, I would miss most of your emails, folks. When you send me emails, they very often go into the spam folder, right? And people tell me that very often my emails end up in their spam folder. And partly it's because I send out a lot of emails. I have a lot of followers, a lot of people who sending me emails. So oftentimes they end up in the spam folder. So now this kind of opens you up to having to be more cautious, because if something's in your spam folder, you got to kind of look at it a little closer. But I've had spam and with social engineering attempts fall into my inbox, right? And it's the spam filters are far from perfect. So just kind of keep that in mind. I check both of them regularly, and I treat them all with skepticism, and I don't click on anything. Kind of hard sometimes because people want to send me documents and pictures and screenshots and whatever. I'm like, no, I will not open this because I get too many social engineering attempts. But my point really here was that social engineering is a critical aspect of attacking and hacking systems. And don't overlook it because it's so important.
So OTW, I want to ask the questions that perhaps viewers might have. What is a group? Because I understand like owner, I understand like everyone else, but when you change the permissions of a group, what group is that?
It's whatever group, that has been assigned. So when I create something, I belong to a group. And so it's going to be whatever group I belong to when I downloaded it or I created it. Now, I can change the group. There is a command called change group. And it's like this. It's sudo change group, like that. And I can change the group. So I can take a file and change what group it belongs to. But it's going to go into the group that I am part of when I downloaded or created the file. In this case here, you can see the group is either root or Kali on my system.
So another confusing thing, OTW, is, okay, so what happens if I'm part of multiple groups? And I also see, like, you've got highlighted there, Kali. So is there some correlation between, like, why is it like root? Why is it Kali? And what happens like if I'm part of multiple groups like sales and whatever?
So what happens is that when you create a user, it also creates a group with the same name. And that becomes your primary group, and your default group. So that when you create a file, it's going to be part of that user and that primary group. Now, I can change the group by using the change group command. If I wanted to put that into a different group. We've covered the basics of the permissions on the Kali system. It's this is kind of a brief chapter in my book. We don't cover a whole lot. From a hacker perspective, I think it's important that you understand that there's different users on the system. Different users can have different permissions. You, as an administrator, can give different people different permissions on different files. And then it's also important to know that there is the thing called the sticky bit, where there is for some binaries that there are root privileges given to regular users when they run that command. That can often be exploited for escalation of privileges.
OTW, just before we wrap up, I wanted to mention your other books, because we're discussing Linux Basics for Hackers, but you do have Network Basics for Hackers and Getting Started Becoming a Master Hacker. We've created a whole bunch of videos about these books, but anything specific you want to mention from one of the books?
Well, we use some of this in all of the books, right? So we in Network Basics for Hackers, we're doing some of the exploitation of various protocols from Bluetooth to SMTP, email, and others. So, if you're really serious about pursuing hacking and penetration testing as a career, it's that Network Basics for Hackers and Getting Started Becoming a Master Hacker are both books that you probably should take a look at and try to do all of the exercises in there, because you're going to learn from doing the exercises about how these things actually work. Don't just read the text. Do the exercises at the end of each chapter.
I always say this, right? You show us some stuff on YouTube, and we get pushback sometimes. It's a common thing on YouTube. You're only showing us the basics, and there's a good reason for that. I'll say this to everyone who's watching. OTW comes to me with a lot of great ideas, and I have to push back and say, sorry, OTW, we can't cover that stuff because, YouTube will pull the channel down. I'll get like a channel strike. But on your website, you can go into a lot more detail, and you've got a new website, right?
Well, we're running two websites right now, and they're basically, there's hackersarise.com and hackersarise.net. They basically have the same content, but different looks. The .net has a newer look. It's our newer, up-to-date website. .com is our older website. At some point, we're going to merge those two together. But right now, you can use both of those websites, both .net and .com. They have the same content. All of our training content we have on a separate, so that when you become a subscriber or Subscriber Pro, we put those classes into a separate website that only our subscribers and Subscriber Pro have access to. So you can access the training at any time. You can come to class, do the live training. Like next week, we have Python Basics for Hackers, and we have Advanced Python coming up. And you can attend those classes live, but if you miss the class, you can always go to the videos and they'll be available on our training platform.
What I really love about what you do in your training is obviously because it's on your website, there's no restrictions like we have here, and you can go into a lot more detail. So if anyone is watching, use the links below. Also want to thank OTW for giving us a discount. So OTW, perhaps you could just tell viewers about that as well.
Well, anybody who wants to go ahead and become a member, subscriber, or buy individual videos, you can use the coupon code BOMBAL, BOMBAL, and get 20% off anything on our website anytime.
Really appreciate you sharing that. And OTW, as always, thank you so much for not keeping the knowledge to yourself. In the old days, I know a lot of people used to, hoard their knowledge. I really want to thank you for sharing for the next generation to make it easier so that they can become like you and perhaps one day become even better than you. Thanks so much.
Oh, I'm sure many of them will become better than me.